Hello, everyone, and welcome back to another session of e-learning. In the last video, we have discussed the different models that have been put forth to explain the structure of an atom. The last model that we discussed was the Bohr atomic model. We have looked at its postulates, we have looked at the applications, and we see that this model seems to be comprehensive enough to give us a clear understanding of what an atom looks like. However, with the advancement of science and technology, we now know that this model has certain limitations. And in this video, I'm going to talk to you about the limitations that this model, that is the Bohr atomic model, has. Now, the first limitation is this model fails to explain the spectra of a multi-atom system. It could explain very well the spectra of a hydrogen atom or a helium ion, but when the spectra of multi-electron atoms was considered, which were more complex in nature, the Bohr theory could offer no explanation for the observation of that. The second limitation was that when the spectra of atoms or ions were placed in an external strong magnetic field, the spectral lines further split up into more lines. This phenomenon is called the Zeeman effect, and once again, the Bohr model offers no explanation for the observed phenomenon. Now, the third limitation was that Bohr he treats an electron to behave as a particle only and not to possess dual character, that is, as a particle and as a wave. We now know through the de Broglie wave equation that an electron is associated with a particle and a wave character. But the Bohr theory is silent about the dual property of an electron. Now, the fourth limitation was that Bohr considers an atom to be revolving around the nucleus in a fixed orbit, just like the planets orbiting around the sun. So according to Bohr, the velocity and the position of an electron in an atom can be determined accurately. But we now know through the Heisenberg uncertainty principle, which states that it is impossible to simultaneously determine the momentum and position of a subatomic particle. If the certainty of the momentum is high, then the uncertainty in the position will also be very high. Now, these are the four limitations. So in order to address the problems of the Bohr atomic model, we have the de Broglie wave equation, we have the Heisenberg uncertainty principle, and we also have the Schrodinger wave equation. Now, combining these three equations, the structure of an atom was further understood to a better extent. So in the next session, when we meet, we'll be discussing about these other equations which are going to make our understanding of the structure of an atom more clear. So thank you for watching this video. God bless.